Good afternoon, everyone. I'm Chris Simmons with GL Sciences, and we manufacture titanium oxide for phosphopeptide enrichment. And today I'm going to discuss some of the advantages and disadvantages of batch enrichment, SP microcolumn, and 2D online LCMS for the enrichment of phosphopeptides. So first off, the phosphopeptide enrichment procedure is the same no matter what technique you use. You're going to retain your phosphopeptides from the sample with an acidic pH, and then you're going to elute those phosphopeptides using a basic or a neutral pH. First off, batch enrichment of phosphopeptides, you'll add your titanium oxide beads directly to your peptide sample, and then you'll do an incubation period for retention, then isolate the titanium oxide beads from your sample for the elution. Usually the isolation is some sort of centrifuge mechanism where then you take the supernatant off and recover the beads. Here's a paper from some researchers in China who investigate the batch enrichment procedure. And the advantage is that you can optimize your bead to peptide ratio to get the best enrichment efficiency. You can also do consecutive bead incubations by taking that collected supernatant and then incubating it again. Consecutive incubations will give you more unique phosphopeptide identifications. They'll also allow you to fractionate your multiphosphorylated peptides from your monophosphorylated peptides. Disadvantages. They're all time related here. Incubations will take at least an hour, not including any other sample preparation that you have to do. Consecutive incubations obviously cannot be performed in parallel. They're all in series, so that adds an additional hour to that time, which is then going to create a very long LCMS sequence. So if you do 8 consecutive incubations, you're looking at 16 hours, 2 days, 3 days max before you can get any usable data from your samples. Next up, we have titanium microcolumn enrichment of phosphopeptides. Here's an example of our product here. We pack titanium oxide beads at the end of a tip. And just like any SBE procedure, you do the same 5: condition, equilibrate, absorb, rinse, and elute. Here's a paper from Larson in the Netherlands where he uses a product, uses our beads, but in a product that's very similar to this. Advantages on this one, they're fast. 30-minute enrichment procedure. Depending on the size of your centrifuge, you can have 12 samples ready to inject in your mass spec within 30 minutes. Pretty high enrichment efficiency, 85+%, and that's consistent for all your sample types, whether you're doing a cell lysate, just a standard digestion, using a gel fractionation, or whatever. Disadvantages of this is your bead and your sample amount are fixed. The only thing you can adjust here is your sample concentration. The recovery of your phosphopeptides, are they all retaining, are they all eluting? Just like with any SPE procedure, that recovery is important. And then the flow through that contains all your unmodified peptides usually cannot be analyzed without some sort of additional sample preparation. You're going to have all different types of buffer, maybe some salt, some other things in there that'll have to be cleaned up. Next, we've got 2D online enrichment. I apologize for the graphic here. It didn't come out as well as I wanted to. But this is from Dr. Heck's lab in the Netherlands as well. And essentially, there's 4 phases. You inject your sample in an acidic mobile phase, and what it'll do is you'll retain all your phosphopeptides on a titanium oxide trap column. All the unmodified peptides will go through to the analytical column. Then you'll run a linear gradient to separate all those unmodified peptides. You'll do your elution, which can either be done by injecting your elution buffer as a sample or switching mobile phases entirely, something that's got a basic component, either ammonium hydroxide or ammonium bicarb. And then that'll elute from the titanium oxide trap column to your C18 analytical column, where you'll run a second gradient to separate those. Advantages. You'll get information on both your unmodified peptides and your phosphopeptides in the same sample. There's really no additional sample preparation required unless you want to do some sort of desalting or removing of detergent. And there's no recovery issues. If your phosphopeptides do not retain to the titanium oxide trap column, you'll see them in that initial linear gradient. Disadvantages. You really have to optimize your loading buffer, your washing buffer, your elution buffer, how much acetonitrile, which acid you're going to use, which non-specific binding inhibitor, if any, that you're going to use for each sample type. What works for a simple digestion may not work for a lysate, and you really have to, and depending on the hydrophobicity of your phosphopeptides as well. It's a complex setup, usually requiring some extra pumps, valve switching capability, or the investment in an instrument that can do this, like Exigent's 2D system. And the Exigent guys can buy me dinner for that plug later tonight. It's also difficult to control your sample concentration, so your sensitivity may be lower than another type of enrichment. Generally speaking, your unmodified peptides are going to be way more concentrated than your phosphopeptides, and that can cause some sort of issue. So again, I'll just sum up here. Batch enrichment will give you the most phospholipid information. SPE microcolumn will give you speed and consistency, while 2D online LCMS will give you the most sample information. So thank you for your time.